Okay, Rabu hari tu kita stop sampai sini kan? Cari cell constants. Okay. Alright. So kita dah dapat, kita dah calculate. Okay, cell constant. Yang ini kita dah dapat value dia 0.212 centimeter negatif 1. Okay, ini dapat Okay, kita move to the next question. Okay. So soalan dia using the same conductance cells. So maksudnya you guna K cell value yang sama, which is kita dapat 0.212. 0.212. As in example 2, the student measured the resistance in resistance dia 19.9 ohm, resistance of a 0.1 molar sodium chloride solutions to be 90.9 ohm. Calculate the experimental value of molar conductivity of this solution. Okay. Now dia nak check calculate molar conductivity of NaCl solution. Okay. Cuba buat. Okay, first step dia. So dia bagi resistance concentration. So kalau ada resistance dengan bukan resistance, okay, conductivity kan. This one, betul lah ni resistance. Okay. So first you kena cari K conductivity. Okay. Dah dapat K, baru you boleh cari calcium. Buat. Ini nanti kita discuss later. Molar conductivity sama dengan conductivity berarti concentration. So, salah lah. Kita lah find ni. Apa pula find cases? Ini salah lah. Dia nak molar conductivity kan find. Conductivity lah. Okay, soalan ni direct lah. Sebab kita dah tahu kan, conductivity, kita dah ada resistance, kita dah ada set constant, dia masukkan dalam equation. Dan bila dia dapat conductivity, you cari dia punya molar conductivity. Okay, buat. Okay, dapat berapa conductivity? Tolong mikrofon dia, saya tak boleh nak buka. Saya punya presentation ni saya kena keluar balik, nanti nak kena tengok. You cakap berapa jawapan dia? Okay, berapa K?
0.107 Siemens centimeter square per mol.
0.107. Alah. Lain?
0.011 ohm per cm.
Okay, betul. 0.011 per ohm per sentimeter. Yang salah tu cuba calculate balik. Okay. Yang lain dapat tak? Okay tak? Yang lain?
Dapat, Doktor.
Dapat Right, next find the molar conductivity. Okay. Berapa molar conductivity? So dah dapat conductivity ni bahagikan dengan concentration. Concentration dia ingat unit molar ni you tukar. Since conductivity ni unit dia Siemens ataupun per ohm lah. So sekarang ni kita tak pakai Siemens sebab dalam ni dia dah ohm, so dia akan jadi per ohm. So jawapan dia mesti dalam per ohm centimeter square per mol. Okay, so ini unit dia. So molar conductivity ni you kena tukar dalam unit centimeter. Mol per centimeter padu kan. Okay. So find molar conductivity. Okay, jadi ni berapa? Okay, dapat. Berapa molar conductivity?
110 Siemens
Betul.
centimeter square.
Betul. 110 per ohm ataupun Siemens lah, sama juga. Siemens per ohm centimeter square per mol. Okay. Mol 110 Siemens centimeter square per mol. Okay, ni jawapan tu. Okay, dapat tak? Yang lain dapat? Okay. Boleh Okay, yang ini cuba buat kat rumah Ni you punya homework. Dia nak apa ni? Okay, carilah dia nak calculate molar conductivity silver nitrate. Okay. Right, ini homework. Okay, now kita nak masuk next part. Kita nak tengok the molar conductivity. So, ingat molar conductivity simbol dia macam ni. Lambda ni. So, molar conductivity behavior of two different electrolytes. Okay. So, apa perbezaan molar conductivity behavior of strong and weak electrolyte? Okay. So molar conductivity ni dia punya definition is to measure the efficiency of the electrolyte to conduct electricity in the solution. Okay. So when most compounds that dissolve in water and undergo ionization ataupun undergo dissociation behave differently either in high diluted solution. Okay. Maksud high diluted solution ni ialah high diluted solution maksudnya concentrations of the solution is low. Concentrations of solution is low, while concentrated solution ni maksudnya concentrations of solution is high. Okay. So dia punya molar conductivity behavior dekat high concentration dengan low concentration behavior berbeza. Okay. So molar conductivity of electrolytes increase with dilutions. Maksudnya lagi dilute the solutions, lagi rendah dia punya molar lagi rendah dia punya concentrations of the solutions, the conductivity, the molar conductivity will increase. Okay. So this variation different for strong and weak electrolyte. Okay, nanti kita tengok. Okay, first kita tengok strong electrolyte. So bila kita sebut strong electrolyte, kita tahu strong electrolyte ni bila dia dissociate, bila kita dissolve dia dalam solution, dia akan completely dissociate. Completely dissociate into ions in solution, kan? Okay. So strong electrolyte ni example dia strong base dengan strong acid. Okay. So untuk strong electrolyte, kita akan rujuk kepada dia punya curve ni lah. So curve ni is a per ohm centimeter square per mole, which is this is a molar conductivity versus per concentration. Okay. Kita tengok contoh satu potassium chloride. Okay. So this is dia punya by experimental value, dia punya molar conductivity at 90% concentration dengan 100% concentration. Okay. So kalau you tengok bila you plotkan dia nampak tak? Dia tak ada significant difference, dia tak terlalu besar. Okay. So what we can see from this diagram, the compound that exhibit molar conductivities that do not change significantly with concentration. Okay. Concentration dia tak berubah banyak. Okay. Do not change significantly with concentration are referred to as a strong electrolyte. Okay. Sebab apa dia punya molar conductivity dia tak banyak berbeza? Sebabnya this is strong electrolyte, it will completely dissociate at all concentration. Okay. So bila you masuk dalam you dissolvekan dalam solution, bila you dissolvekan dalam water, dia akan completely dissociate into ions. Okay. So that's why bila you plot dia punya graph, dia punya variations of molar conductivity are not do not change significantly. Okay, dia tak jauh berbeza. Okay. Then you tengok ya, this one per concentration, this is a molar conductivity. So maksudnya belah ke sini, ke kanan dan belah ke kiri, this is more concentrated, kan? Concentrated. This one more diluted the solution. Okay. So molar conductivity ni dia akan increase slowly with dilution. Okay. So you kena ingat molar conductivity increase with dilution. Lagi dilute the concentration of the solution, lagi tinggi dia punya molar conductivity. So molar conductivity increases slowly with the dilution. Okay, nampak ni kat sini kan. Dari point sini, 1.2, 3, 4. 5, 6, 7. Nampak tak? Dia punya kenaikan of molar conductivity do not change significantly with the concentration. Okay. So there is a tendency for molar conductivity to approach a certain limiting value when the concentration approach 0. Okay. So kalau kat sini concentration, kat point yang sini concentration dia akan jadi kosong kan. Okay. So dekat sini molar conductivity, there is a tendency for molar conductivity to approach a certain limiting value when the concentration approach 0. Okay. The molar conductivity when the concentration approach 0 is called molar conductivity at finite dilution ataupun kita panggil limiting molar conductivity. Okay. So dekat point sini, okay, bila concentrations of the solution become 0, molar conductivity dia akan jadi limiting molar conductivity. Okay. So dekat point sini. So kalau kat point sini, it is the limiting molar conductivity. Okay, faham tak? Boleh tak?
Boleh doktor.
Okay. So when concentration approach 0, molar conductivity akan jadi limiting molar conductivity. Okay. For strong electrolytes, molar conductivity increase slowly with the dilution and can be represented by this equation. Equation ni kita panggil dia Debye-Hückel-Onsager equation, where molar conductivity equal to limiting molar conductivity minus beta times per concentration. Okay. So this one molar conductivity, limiting molar conductivity, this one per concentration, and beta is a constant value. So this beta akan depends on the types of the electrolyte. Okay. So dia bergantung lah electrolyte dia. So maksudnya dia ada value dia sendiri. Okay. Different electrolyte probably dia ada different value. Okay. So what we can conclude from the graph, from the graph it has been noted that the variations of molar conductivity with concentration is small. Okay. So molar conductivity variations dengan concentration is small, kan, they do not change significantly. So that's why bila kita plot the graph, okay, kita boleh extrapolated. Maksudnya graph ni dia boleh potong lah dekat when the concentration is 0. So that the plot can be extrapolated to 0 concentration. So dekat point ni, when concentrations equal to 0, molar conductivity akan jadi limiting molar conductivity. So the intercept is equal to limiting molar conductivity and the slope is negative beta. Okay. So apa yang kita boleh conclude untuk strong electrolyte? Okay. So strong electrolyte dia akan dissociate fully into ions when dissolved in the solution. So molar conductivity, okay, so molar conductivity boleh yang ni, is only the weakly dependent on concentration for strong electrolyte. So dia tak bergantung, dia weakly dependent on concentration. Okay. Molar conductivity ni dia weakly dependent on concentration for strong electrolyte. So that's why bila you plot a graph untuk molar conductivity ni, kita boleh extrapolate dia sampai point sini lah. So bila kita when the concentration approach to 0, molar conductivity ni dia akan jadi limiting molar conductivity. Okay. That's for strong electrolyte. Okay. Now kita nak tengok perbezaan weak electrolyte. Kan? Bila you tengok graph ni, this is for weak electrolyte, this is for strong electrolyte. Ada beza tak? Beza kan? Okay. So for strong electrolyte, since when it be dilute in the solution, dia akan dissociate completely into ions. Kita tahu lah, strong electrolyte dia punya behavior macam tu. So dia punya molar conductivity akan weakly dependent on concentration. But for weak electrolyte, so kita tahu weak electrolyte dia akan partially dissociate into ion when dissolved in the solution. Okay. So kalau you tengok conductivity, the behavior, molar conductivity behavior for weak electrolyte dia berbeza. Dia ada variation. Okay. So for weak electrolyte, contohnya acetic acid. Okay. For example, weak electrolyte, weak base ataupun weak acid. Okay. So for weak electrolytes, okay, are nearly completely ionized at low concentration. Okay. So kita tahu kan, ke sini more concentrated the solution. Kalau belah ke kiri, more diluted the concentrations of the solution. Okay. So for weak electrolyte, it is nearly completely ionized at low concentration. Kan nampak tak? Dia near, hampir kan? Dia punya concentration dia nearly completely ionized. Tapi dia tak 100% lah. Dan ini I think kita tak boleh letak 100% lah. Kita letak 90% lah. Okay. But incompletely ionized at higher concentration. Nampak tak? Lagi dilute the solution, dia punya ability dia takkan incompletely ionized into ion. Okay, dia takkan fully dissociate into ions. Okay, lagi concentrated the solution, tapi lagi diluted the solution, lagi diluted the concentration of the solution, dia nearly completely, dia hampir untuk ionized completely. Okay. So their dissociation is strongly concentration dependent. Okay, untuk weak electrolyte maksudnya dia strongly depend on the concentrations of the solution. Okay. So untuk weak electrolyte sama juga molar conductivity versus per concentration. The variations of molar conductivity with concentrations is very large. Kan nampak tak besar kan? This one 90%, this one 20%. Lagi besar dia punya variation. Therefore, we can obtain molar conductivity at infinite dilution by extrapolations of molar conductivity versus per concentration plots. Okay. Daripada curve ni, kita tak boleh extrapolate. Jadi kalau strong electrolyte, kita easily to extrapolate the graph kan. So dekat point ni kita boleh dapat limiting molar conductivity. Tetapi untuk weak electrolyte, we are not able to extrapolate. Sebabnya dia tak completely ionized into ions, but it is a partially. Okay. So at diluted concentration, dia nearly completely. So that is why dekat point ni, kita tak boleh dapat molar conductivity, limiting molar conductivity untuk weak electrolyte. Tetapi kita boleh calculate limiting molar conductivity by using equation lah. Nanti kita akan tengok. Okay. Tetapi by plotting the graph, from the graph kita tak boleh extrapolate dia. Okay. Untuk weak electrolyte. Sebab apa? Dia punya variations of molar conductivity is very large. Okay. For weak electrolyte. Okay. So that's why for molar conductivity, for weak electrolyte, we can conclude that the molar conductivity is strongly dependent. It's strongly concentration dependent. Is strongly concentration dependent for weak electrolyte. Okay. So ini dia punya conclusion. Right. So boleh buat tak kalau ada soalan, dia punya what is the molar conductivity behavior for weak dengan strong electrolyte. Boleh eh? So you boleh lukislah dia punya graf ni, tunjukkan perbezaan dia. Okay, from the graph apa yang berbeza. Okay. So you tengoklah variation dia, satu small, satu besar kan. Satu kita boleh extrapolate, dia dapat limiting molar conductivity. Okay, bila concentration equal to 0, okay, for weak electrolyte kita tak boleh extrapolate kan sebab dia punya variation is too high. Okay. Satu, for strong electrolyte kita boleh katakan molar conductivity dia is weakly dependent, but for weak electrolyte dia punya molar conductivity is strongly concentration dependent. Okay, boleh? Ada soalan?
Jelas doktor.
Jelas ya? Alright, now kita tengok the explanation for the variations of molar conductivity with concentration. Okay. So kalau for strong electrolyte kita tahu dia punya molar conductivity variation is small. Okay. And it is a not weakly concentration dependent. Okay. So conductance behavior for strong electrolyte, first the number, no increase in the number of ions with the dilution. Okay. So maksudnya lagi dilute the solution, the number of ions dalam solution tu dia tak ada perubahan. Okay, sebab apa? Dia completely ionized in the solution at all concentration. Sama ada weak, sama ada diluted solution ataupun more concentrated solutions. Okay, so first, sebab apa dia punya conductivity behavior is weakly dependent? Sebab no increase in the number of the ions with the dilution. Okay. So, in the concentrated solution, for strong electrolyte, dia punya interionic forces is strong. Okay. That's why you akan dapat the molar conductivity dia berkurangan. Apa tu interionic forces? Kau boleh bagi tahu apa tu interionic forces? Interionic forces, it is a forces of attraction between the ions of the opposite charge. Okay. So forces yang charge yang berbeza. Okay. Forces of attraction between the ions of the opposite charge. Okay. Tarikan charge yang berbeza. Okay. So untuk concentrated solution, dia punya interionic forces is high. Then molar conductivity dia is low at concentrated solution. Tapi untuk diluted solution, dia terbaliklah daripada concentrated, interionic forces dia berkurangan, low kan, sebabnya number of ions tak ada perubahan. That's why dia punya molar conductivity dia akan increase with the dilution. Lagi dilute the solution, molar conductivity dia lagi tinggi. Okay. So bila concentration dia equal to 0, dia boleh approach a limiting molar conductivity value. Okay. So that's the explanation between for strong electrolyte. Okay. Untuk kalau weak electrolyte, kita tahu for weak electrolyte dia punya molar conductivity dia depend on the concentration. Lagi dilute the solution, lagi tinggi ke rendah dia punya molar conductivity? Lagi tinggilah molar conductivity dia. Okay. So the number of ions produced in solution depends upon the degree of the dissociation. Kita katakan degree of the dissociation, dia punya simbol kan, alpha ni. Okay. So for weak electrolyte, degree dissociation dia besar ke kecil? Ingat tak? Recall back waktu kita define mula-mula. Okay. So untuk degree of dissociation for weak electrolyte, dia punya degree dia dissociation selalunya equal to 1. Okay. So untuk equal to 1 ni untuk for strong electrolyte. Kalau weak electrolyte dia less than 1. Okay. So molar degree of dissociation for weak electrolyte is less than 1. Okay. Okay, for weak electrolyte, lagi dilute the solution, the degree of dissociation increases as a result of molar conductivity increase. So at infinite dilution, the electrolyte is completely dissociate so that the degree of dissociation becomes 1. Yang ini statement ni dia tak terpakai kepada seluruh weak electrolyte lah. Tapi sebenarnya kita tahu for weak electrolyte dia partially dissociate into ions kan. And then lagi dilute the solution, dia nearly to dissociate. Dia takkan 100% lah. Okay. So this statement ni kalau kita tengok balik, dia sesuai untuk concentrated solution. Okay, tapi untuk weak electrolyte, dia takkan dapat lah. I think lah, I'm not sure lah, tapi dia nearly dissociate kan. Kan kita tengok tadi, dia punya, kalau by this curve kan, dia takkan dapat, probably tak tahulah. Mungkin ada certain electrolyte dia boleh kot. I'm not sure lah. Tapi kalau based on kita punya curve ni, kita tahu dia lagi dilute the concentration of the solution, dia nearly to dissociate. Okay? Alright. So ini another equations, the degree of dissociation. So kita boleh calculate the degree of dissociation where equation dia equal to molar conductivity divided by limiting molar conductivity. Okay. So ni another equation. Okay, kena tahulah. Okay. So degree of dissociation, the molar conductivity of weak electrolytes such as organic acid exhibit a very different behavior. Betul. At higher concentration, they have a relatively low conductivity. Betul. But at very low concentration, maksudnya lagi dilute dia punya concentrations of the solution, they rapidly approach conductivities that comparable to those of strong electrolyte. Okay, ni betul lah statement ni. Yang sama tadi. So kita boleh calculate degree of dissociation. Kenapa kita upload kat sini? Okay, ini equation dia, molar conductivity divided by limiting molar conductivity. Apa sini pula? Oh, ini dia refer kepada Arrhenius. So Arrhenius assume incomplete dissociation at higher concentration, betul, but complete dissociate at infinite dilution. Okay. So he therefore considered the low molar conductivity at high concentration to be a good degree of dissociation. Okay. So example 3 ni dia nak apa? Calculate the degree of dissociation for the solution. Okay. So dia bagi kat sini molar conductivity. Alright. Yang ini, okay, untuk soalan, kalau ada soalan ni, selalunya dia akan bagi you table. Table yang ada value of limiting molar conductivity. So from this table, you boleh tengok lah. This is a limiting molar conductivity of some electrolyte, hydrochloric acid, HBr, NaCl, KBr, KCl, and so on. Okay. So each of the solution, dia ada dia punya limiting molar conductivity value. Okay. So kalau soalan macam ni, calculate the molar conductivity of NaCl. So kita tahu, calculate the degree of dissociation. Example 3, molar conductivity for 0.1 molar sodium chloride is 107 Siemens centimeter square per mole. Calculate the degree of dissociation for the solution. So dia nak alpha ni. So kita tahu alpha equal to molar conductivity bahagi dengan limiting molar conductivity. So ni untuk NaCl. So molar conductivity ni kita dah tahu 107. Dia punya limiting molar conductivity ni kita ambil dia dekat sini. 12645. Ni cuba calculate dapat berapa?
0.8462.
Ya, betul tak? 0.846. Okay. So jawapan dia 0.846. Ada unit tak? So yang ini tak ada unit lah kan. Ni bila kita dah cancel up dia tak ada unit. Okay. So degree of dissociation dia tak ada unit. Okay, yang ni simple je, direct je. Okay, boleh ya? Berapa dah? Kita nak tahu dulu. Ya, kita tengok. Dan portion kita nak continue. Sekejap, saya tengok. Kita nak proceed portion ni first. Kita stop kat sini. Minggu depan minggu yang ke 1, 2, 3, minggu keempat, minggu depan minggu ke-5, minggu ke-6. So, minggu ke-6 kita dah kena habis chapter 3. So, sekejap kita tengok kita boleh stop kat sini ataupun kita continue sampai progress law ni. 1, minggu control, transform electrolyte, with electrolyte, culture, system. Okay, kita masuklah sikit. Lagi cepat habis, lagi senang kita nak buat revision nanti. Okay. Alright. Ingat tak tadi kita punya graph ni kan, kita punya curve ni kan. Untuk strong electrolyte, it is easily to determine the limiting molar conductivity by extrapolating the curve. Okay, bila concentration equal to 0, molar conductivity equal to limiting molar conductivity. Okay. So untuk strong electrolyte dia tak ada masalah. Tapi untuk weak electrolyte kita tak boleh extrapolate dia kan. Sebab dia punya diluted solution dia nearly completely ionized. Okay. So kita tak boleh dapat limiting molar conductivity by plotting the curve. Tetapi kita boleh calculate the limiting molar conductivity value of the weak electrolyte by using Corrosh law. Okay. So Corrosh law stated that at infinite dilution, the ions act completely independently and the limiting molar conductivity will obey a rule of additivity. Okay. So yang ini maksudnya for strong electrolyte, kita boleh dapat value dia daripada graph dan juga boleh guna equation yang ini. Okay. So untuk strong electrolyte, dia punya equation limiting molar conductivity for AX solution equal to limiting molar conductivity AY plus limiting molar conductivity BX minus limiting molar conductivity BY. Nanti saya tunjuk apa tu BY, BX, AY, AX ni. Okay. So AX, AY, BX and BYs are strong electrolyte. Okay. Ini equation untuk calculate limiting molar conductivity for strong electrolyte. Tetapi untuk weak electrolyte, ni dia punya equation. So for weak electrolyte, molar conductivity can be deduced from limiting molar conductivity values obtained from strong electrolytes. Okay. So ini equation untuk calculate limiting molar conductivity for weak electrolyte. HAC ni, this one weak electrolyte. Okay. HX, MA, MX, ini semua strong electrolyte. Nampak tak perbezaan dia? Okay. Yang ini semua strong electrolyte. But this one semua, yang belakang ni semua weak, strong electrolyte tapi kita nak cari weak electrolyte. Okay. Boleh? Yeah. So you jangan keliru lah between strong dengan weak electrolyte. Dia punya equation dia lain sikit. Yang ni AX equal to AY, BX minus BY. Yang ni HA equal to HX plus MA minus MX. Okay, kita tengok satu contoh. Okay, don't worry, selalunya kalau dia nak suruh you calculate, dia akan bagilah dia punya value sama ada dia masukkan dalam soalan ataupun dia bagi table. Okay. So this is all the table listed. Okay. So this is molar conductivity of some strong electrolyte. Kita tengok satu contoh. Ini ke? Kita nak buat. Sekejap ya. Info 3. Okay, bukan yang ni. Yang ni nanti kita pakai equation yang lain. Okay, kita nak tengok yang ni. Kita buat satu contoh. So that you boleh faham. Ni contoh saya ni jawapan dia. Apa pelik-pelik. Nota ni lah. Nota ni lah. Okay. So kalau you perasan kat dalam soalan ni dia tertinggal unit. Okay. So unit dia sama je. Kalau limiting molar conductivity, unit dia sama juga dengan molar conductivity. Siemens centimeter square per mole. Yang ni dia tertinggal unit. Dia terlupa nak masukkan. Okay. So now dia nak calculate the limiting molar conductivity for weak electrolyte. Dia dah mention kat sini. Okay. Apa yang weak electrolyte? It is ammonium hydroxide. Ammonium hydroxide. Okay. From the molar conductivity values for this strong electrolyte. Okay. Dia dah bagi macam ni. Okay. Apa equation yang kita nak guna? Ingat tak?
Yang HA tu.
Yang ada HA, okay. So limiting molar conductivity, kita tengok, kita list dulu. HA equal to limiting molar conductivity HX plus limiting molar conductivity MAC minus limiting molar conductivity MX. Okay. So, kita nak calculate limiting molar conductivity NH4OH. Okay. So, dekat sini kita boleh bahagikan dia siap-siap. Okay. So, you pecahkan sini. NH4 dengan OH. NH4 ni dia akan jadi H. OH ni dia akan jadi A. Betul. Okay. So, dia akan sorry. Dia tak lekat. Okay. So, yang ini sama dengan limiting molar conductivity apa? H kita dah identify dah. H is NH4. Dalam ni mana NH? Ada yang ada NH4?
NH4Cl.
Okay. So, yang ini kita dapat NH4Cl. Okay. Again, kita separatekan dia. So, NH4 ni kita dah tahu tadi kan? So, dia akan jadi H. Cl ni dia akan jadi X. Nampak tak equation yang ini? Alright. Next. Plus. Apa? M kita tak tahu tapi kita tahu A. A is OH. Yang mana ada OH?
NaOH.
Okay, so kita kat sini. NaOH. So, NaOH. OH kita tahu dia A. So, Na ni dia akan jadi M lah. Nampak tak? So, dia akan merujuk kat sini. M. Na. A ni akan jadi OH. Okay, next. Seterusnya. Minus molar conductivity. M kita dah tahu. Which is Na. X kita dah tahu. Cl. So, dia akan jadi NaCl, betul tak? So Na ni akan jadi M, Cl ni kita tahu dia X. Alright. So inilah dia HA, HX, MA, MX. Okay, cuba calculate dapat berapa? Masukkan value dia. NH4Cl 149.7 tambah NA for which 248.10 tolak dengan NaCl 126.5. Dapat berapa?
271.3.
271.30 unit dia Siemens centimeter square. Oh, ya. Okay, boleh? Dapat tak?
Dapat.
Boleh? Senang je, ikut rules dia. So, you kena tahu, you hafal lah. Between, this is for strong electrolyte and this is for weak electrolyte. So, sama juga untuk strong electrolyte, you pecahkan tadi. AX ni apa, AY apa, BX apa, BY apa. Okay, sama macam saya buat dekat weak electrolyte tadi. Boleh? Nanti kita berbagi contoh-contoh yang lain. Alright, okay. Ada soalan? Kita stop sampai sini. So, kita continue next week. Okay, attendance. Pergi tick dekat U Future. Now, buka U Future. Tick attendance untuk hari ini. Saya dah assign kan. So, kalau dah tick attendance, okay, boleh, kita boleh bersurai lah. Okay, terima kasih semua. Assalamualaikum.
Terima kasih doktor.
Thank you,
Okay.
doktor.
Terima kasih,
Thank you,
doktor.
doktor.
Sama-sama.